Good afternoon. This is Becky Brown from 8K Miles, and I'd like to welcome you to Migrating Your Applications to Microsoft Azure. 8K Miles is a cloud and security company. We specialize in providing solutions for our customers that are easy to consume and fill gaps in the marketplace. 8K Miles has developed a set of best practices and frameworks that encompass security, compliance, automation, and operations. These practices allow organizations to quickly reap the benefits of Microsoft Azure. 8K Miles is a Microsoft Cloud Competency Silver Partner. We have chaired and influenced many of the standards our customers use today. Today's panelist is a Cloud Solution Architect for 8K Miles. Mr. Ilyas is a certified Azure Solution Architect with a deep expertise in designing, developing, and architecting solutions for the cloud. He's worked on many migration and integration projects on Microsoft Azure. Before I turn it over to Ilyas, just a reminder, if you do have questions throughout the presentation, please type them in and we'll address them at the end. Ilyas, I'll turn it over to you.
Thanks for the introduction, Becky, and I would like to thank the participants who have joined this webinar today. So the webinar topic is on migrating applications to Microsoft Azure. So to give you a context of what this webinar is going to be, it's actually a collection of various experiences that we learned over doing a migration activity of migrating an application from a customer on-premise to Microsoft Cloud. And throughout this particular engagement, we learned many things. We faced a lot of challenges. We did informed, options. We took informed options in certain cases. So we feel the content that we are going to deliver on this webinar will be very useful when you get into similar engagement while you migrate your applications from your premise to cloud within your company or outside of your company. So as you could see on the agenda list, we'll first understand what the customer is and who the customer is, and then what their challenge was. And then we'll look at the detailed analysis that we did for this particular engagement, and the migration strategy and plan that we came up with for migrating their application to the cloud. And we'll also look at the key considerations on both the application as well as the database side, while you involve yourself when migrating the applications plus the databases to Microsoft Azure. And finally, we'll also learn the benefits realized by this particular customers, and then we'll finish the webinar by giving the key lessons learned as a key takeaway for you. Now let's get into the understanding what the customer and their challenge is. So our customer was a leading apparel manufacturer in the U.S. And so they had a reasonably sized, or I could say modern to large sized line of business application, which was used by their internal users, their employees, as well as their customers and their end users for doing various operations about the manufacturing process, as well as to understand their products and things like that. So this application was used by around 20,000 users at any given point of day. And it was a very read and write intensive application. The entire application is built on the Microsoft stack, such as the IES, .NET framework, the C#, and the SQL Server as the backend. And this application was hosted on a web form with about 6 to 8 servers hosted on their corporate data center, and it was holding around 500 to 600 GB of data spread across both the SQL Server as well as the storage network and things like that. And if you look at the challenges are very typical and very familiar. These challenges are already talked about much when it comes to challenges of having and hosting and serving applications from on-premise, right? So the key challenge is the scalability challenge, because unlike other kind of workloads and customers that we have dealt with, this particular customer had a predictable workload and predictable scalability patterns, right? So the difference between the predictability and unpredictability is Predictable workload is that the customer very well know that the workload is going to go high in next couple of months because the customer wanted to get into new markets, manufacture new kind of fashion apparel. So they very well know that the peak load, the workload is going to go high. But unfortunately, they had to withstand the entire load with their existing server set because buying and stacking up and racking up new servers, will not require after the peak load, goes down. So the scalability and higher availability was always been a challenge for this customer because of the improper configuration setup of the network, the server itself, the application, hosting itself on their on-premise. And other set of challenges, the cost itself, right? So every time when they want to do a scale up or when they want to buy new software or hardware, they have to procure, and the procurement time itself took a lot of time, and also the manpower to to manage the IT operations and a lot more things on the cost side. So these various reasons push the customer to look at the cloud alternatives, and especially Microsoft Azure, to move their existing workloads from on-premise to Microsoft Cloud. So looking at the approach, right? So we took a three-stage approach to migrate the application from their corporate firewall to the Microsoft Azure Cloud. So as you could see, the first stage is analysis, the second stage is assisted migration, and third stage is testing and rollout. Let me give you a brief introduction about what assisted migration is. Assisted migration is a proven methodology or model where we as a cloud experts engage with customers' engineers throughout the application migration process, right from the analysis till we move the application to the production and the customer starts using it even after the management process and things like that. So it's a very active and useful model for both the migrators as well as the developers and end customers to get a seamless cloud migration, smooth cloud migration. So let's understand what we did on the analysis phase. So on the analysis stage, as we saw in the previous slide, we closely worked with their developers because they had, they are the one who have developed this application for many years, and they know, and they have a lot of domain skill set as well as they know the application deep. So we sat with them together, understand the application architecture and the infrastructure, where it is hosted and how it is hosted, and the dependencies between application and how many other applications are dependent on this, or are there any other components which actually reads and writes data to it, or are there any custom modules built into this application? So how can we port these modules into Azure Cloud? So we did a lot of analysis on the application architecture side. And apart from these analysis, we also analyzed for various other parameters such as compatibility. So which cloud tier would be the right tier for this kind of application, and the criticality, the cost efficiency, and then high availability requirement, especially RTOs and RPOs, the recovery time objective and recovery point objectives. These are the key parameters for making any application highly available. And then identifying the suitable migration strategy. So if you look at the migration itself, right? So there are multiple ways where you can port applications from on-premise to cloud. So the first option is lift and shift, where you simply move your entire VM or the application and throw it into cloud. The second and third one is refine and rebuild, where you modify your application a bit to adopt the cloud, the scalability and performance by adopting the key services offered by Azure. And rebuilding, as you could understand, it's, I mean, if you believe the customer is that the application is not suitable for the cloud, or if you believe you cannot achieve the efficiency or cost performance or higher availability with the current application, so the better way is to rebuild the entire application. But for this particular workload, we took a unique approach by combining, refining, and rebuilding by incorporating the certain key services offered by Azure to make the application more highly available and scalable in nature with more cost efficiency. So while we do that, so we have to identify what would be the right cloud model to port the application and what would be the right database end for porting the SQL Server data to cloud. So with respect to the compute, there are various options that Microsoft Azure offers. So the key option with respect to the compute is PaaS and infrastructure as a service, that is IaaS. And on the database side, you got options like SQL Azure versus SQL Server on a VM. So SQL Azure is nothing but a scaled down and simplified version of SQL Server as a service against running your own SQL Server on VM, and you have to patch up the server where the SQL Server is hosted. So it's very regular, typical SQL Server that sits on our premise. And if you look at the compute, PaaS abstracts the lot of IT challenges that we face in a typical IT environment where you have to back up, you have to stack up, you have to load the OS and then patch, manage the OSs, and things like that. So PaaS abstracts all these challenges and then lets the developer concentrate more on the application and developing more new features and pushing those features into the production as soon as possible. So we took a very informed decision as to go with PaaS and SQL Azure based on the application nature and based on the future need and based on the developer agility that these services give. And we also analyzed the existing workload, the user access, the pattern, and then we also predicted the future workload of the application based on the inputs from the customer. And based on that, we chose certain tiers with respect to both Azure VM, with respect to the cloud services on the compute side, and the right service on the SQL Azure side. So we'll also delve deep into those aspects in the upcoming slides. And while you refine and rebuild your application, it is also very key to throw out certain components from your application. So we'll also look deep into that on the next slide. So we chose certain services such as SQL Azure or Azure CDN or other components we'll also see. So this is the Azure service mapping. So where I talked about replacing the existing components or technologies used on premise and moved out to a new set of services which is more highly available and scalable as well as cost efficient while you adopt these services. So we moved from regular SQL Server on the VM hosted on premise to SQL Azure, and then so while we analyzed the data set, we found many data which was residing in the SQL Server, a kind of schema-less, key table, key value pair kind of data. So we thought the Azure table would be a best fit. So we adopted that and we migrated to Azure tables. And there are a lot of benefits that Azure tables provides. It's way more scalable, and it's so cost efficient when compared to storing these schema-less or key value pairs in the SQL Server. And then it is generally advisable to move out from in-process cache or cache stored in state server or SQL Server to a highly available and high performance cache system, that is Azure Redis cache. So the Azure Redis cache takes away your cache the stored in the in-process and moves into highly available and redundant Redis cache system, which greatly improves the performance of the application that we migrated. And the application was highly heavily dependent on the text search capability of the application. Almost all the pages of the application had some way or the other text searching mechanism, be it finding certain apparels or be it finding certain inventories. So so the application, was such that it was very read and write intensive, and search experience was pretty much bad in the on-premise application. So we suggested and adopted Azure Search for this particular engagement and moved those searchable data to Azure Search. And adopting Search, although it has a little learning curve for anyone who implement Azure Search, but then it is highly, it provides a lot of performance and highly advisable to adopt Search for offering better search experiences for your end users and customers. And similarly, we also moved out from custom queues to Azure Queue. So through the application, and thanks to the developers who developed the application, because it was at least certain, almost 80% of the application was stateless. It built in a stateless fashion. But certain area was still sticky, right? So those developers were built custom queues to handle the queuing process between one models to another models to connect one one particular component to another component. So we moved out of custom queues and adopted Azure queues, which is again highly fault tolerant and scalable and highly available services on Azure. Static assets. Nearly any application for that matter uses a lot of static assets, be it image files or video files or text files or document files, any kind of PDFs or JavaScript. So the recent report says that all the web application which serves the static files from the application server itself suffers from 50% of bandwidth. So when you move the static files from your application server to the dedicated Azure storage and blobs, improve the performance as well as decrease the bandwidth taken by these static assets, which will also makes your page load faster, 10 times or 20 times faster when you adopt this particular service. Right. So now let's look at assisted migration with respect to the application side. In the application side, as I said, we adopted cloud services against the websites and against the Azure regular VM, that is infrastructure as service. We chose this option because the particular application that we engaged with had certain HTTP modules and it required certain access at the OS level. So if you do not want OS level access, or if you don't have any module that goes up to OS, or if you don't want GAC level access, probably you can better stick with web apps. Or if your application is very complex or legacy, if you don't want to modify or refine or rebuild better, you can go with the Azure VM. So always do not use the local storage to store any kind of files. Because it is very typical that developers and architects may store the temporary files or XML configuration files on the local storage of the particular server. But it is always advised to store in a persistent storage like Azure Blob or queues and tables, because the local storage you may not know when the server will go down. Those static files, those temporary files may stick if the OS gets rebooted, but if the server itself goes down and if Azure boots up a new server, those files, whatever you have stored on the particular temporary storage, will wash off. So always use persistent storage to store anything that you want to store for a longer time. And always manage your session data in Azure Redis Cache. And again, we suggest you to adopt this particular service because it greatly improves the performance of the entire system. Because many of the existing applications that we have dealt with, but not this particular application, was hugely dependent on the in-process cache for storing the sessions data, and especially for the web forms application built over the years. So move out of the session data, storing in process or in the same server, and adopt Redis Cache. And then serving static files from CDN will also greatly improve the page load, as well as it will reduce the bandwidth. And the load balancer plus traffic manager to achieve higher availability, because this particular customer had users and customers accessing this application throughout the world, and especially customers and users from Europe and the Asia Pacific region, and mostly users from the US region. So we set up the servers in such a way that 3 servers on the US West and 3 servers on the Europe West, so that when the customers access the application when the users access the application from the US, the traffic manager intelligently serve those requests and point those requests to the particular server hosted in Europe. And similarly, if the user comes from US, the traffic manager plus the load balancer combination will automatically push them process the request from the US region. So it's always suggested to use both the combination if you have user access from across data centers from across different parts of the world. And similar security concepts that we have in the VM, such as you can set up your access control list, where you can say from which IP address should we allow users to access the application. And you can also set up HTTPS for SSL and TLS for your web application. And then you can also set up firewall for both the client firewall as well as server firewall for better improving the security of the application where it is hosted. And as I suggested, it is always good to store your binary files on the Azure blob. And if you have any queue-like system, use the Azure queues and go for tables if you have a schema-less data set or key value data set where you can, which is also growing very fast, right? So you can go for Azure tables. And one of the reason or one of the challenge that developer had when the application was on premise was the lack of visibility throughout the entire life cycle of the application. And I mean they were also using the contemporary FTP system to push the new changes to the staging environment, from there pushing into the production environment. So we introduced the continuous integration, that is Visual Studio Online, offered by Microsoft, to continuously integrate codes or new features and functionality developed by developers, and test it on the cloud using the continuous integration solution, and push it to the production environment. So this offered a greater agility for the developers to seamlessly push and build and test the application, and finally push the code to the production environment. So like we saw the certain key considerations on the application side, there are a lot of other important aspects on the database side as well. So to begin with, always look at your data, the type of data, and the growth and the access pattern, the IOs, and based on that, choose the right tier, because Microsoft Azure provides a different pricing and tiers, such as standard, the basic, or the premium. For this particular case, we gone with premium because of the read intensive and write intensive data that we had, and also the application was critical. So we gone with the premium database tier because it provides geo-replication, geo-redundancy, where it keeps active data set in multiple regions or in a multiple different data center, which offers higher availability and better backup and DR strategy. And you used Azure Elastic Scale API for database scalability. One of the key, I would not say limitation, but the key aspect of going with SQL Azure is it has certain key pointers, such as database size, right? If you go with standard Azure SQL standard, there's a hard limitation of 250 GB per server. And similarly, if you go with premium, the set limit is 500 GB, right? So beyond that, if you want to scale, you can use Elastic Scale API, which will help you to shard your data to more than one database. And this is highly advisable, especially for the SaaS kind of application, where they may want to roll out new shard as and when they get a new customer, or if they want to shard a hugely growing database, they can also use this particular Elastic API, which completely abstracts the complex technique and technology that you have to build to shard the database layer. So this greatly reduces the time and effort that the developer has to go through the elastic scalability, because scaling on the database end is always difficult. But with the elastic scale, using Azure, SQL Azure, helps the developer to concentrate more on the database, writing new features, instead of worrying about the scalability part of the database itself. And TDE, the transparent data encryption for security, which helps developers to encrypt the data at rest, is also supported on SQL Azure. So because we have certain tables within the database that we migrated was little critical and have to be really secure, because those tables on the on-premise were also encrypted. So we had to encrypt those tables even after migrating to Azure. So we utilized transport data encryption for securing those particular tables. And index is a key part of providing a better experience, the database query experience, for the application. So you have to continuously rebuild, because it continues writing data. This particular application was way more write intensive, so it writes continuously new data. So we had to rebuild the entire index and reorganize. So we use the Azure scheduler, which is a highly available scheduler as a service component of Azure, which will help you to call any services on a particular scale or automatically. Right. So we use this particular service to rebuild the index, as and when we want, and whenever we got new data. And on the data migration itself, there are a lot of utilities available. There are offerings from Microsoft and offerings from ISV third-party companies as well. But there are plenty of tools Microsoft itself provides, such as Azure SQL import service, export service, and database copy, SSIS you can use, SQL Server import export. But this particular engagement, we gone with SQL bulk copy, where it migrates the entire data and the schema to Microsoft Azure. Okay, and finally testing and rollout. So it's key to test the application continuously before you move the application from staging environment to the production. So the key lessons here is, do not load test the application when it is fronted by Azure CDN, right? Because Azure CDN is already proven and it can scale to millions of IOs. So it's ultimately wrong to load test your application when it is fronted by Azure CDN. So please do not do that. And then there's the load balancer for performance, right? So you got load balancer as well as traffic manager. So always see which particular model gives you the better performance. So you can go for performance-based balancing algorithm for traffic manager, and for the load balancer you can try with different models such as round robin, or even you can go for least used algorithm, or you can go for performance-based load balancing as well. And always test the expiry of session data when you use the Redis cache, because you should not serve the stale data from the Azure Redis cache. So be very careful on this side. And also configure the proper backup and recovery mechanism, because the Azure itself, the various components that we just discussed, they themselves are highly available, and they themselves provide resiliency and proper redundancy and things like that. But you can also manually set up backup if you want. And then test and tune the app continuously. Test and tune the application as well as the database for better performance of both. Okay, so now let's look at the migration execution. So in the migration execution, you could see how much of man resources and how much of time that we took and implemented the entire migration from on-premise to cloud. So I mean, totally it came about 9 man months, but we could entirely with the help of assisted migration, with the help of the developers, we could easily and seamlessly migrate, analyze, and then test and roll out the entire solution to Microsoft Azure within a time frame of 2.5 months. So here you could see, I mean, we came up with a proper delivery, who works on a particular task, and on the migration side, how many developers, architects, and which implementation model, what is the delivery again on the migration, and finally on the test side, the deliverable was set very clear. So let's quickly understand the benefits realized by the customer, because end of the day, why we are engaging or why we are moving the workloads from on-premise to cloud is to fix the challenges that we had on-premise. So on this side, the scalability was improved to handle up to more than 2,500 RPM requests per minute, and the availability with the help of Azure SQL kind of services and the PaaS, the cloud services of Azure also helped greatly to increase the availability up to 99.8%. So we also did a trial and test dry run to check how the availability works. So we switched off certain region, we switched off certain VMs and see how it works. So it worked very perfectly. It was able to seamlessly fail over from one server to another server, from one region to another region. Thereby, we came up with this number that is the applications available all the time for up to 99.8%. So the customer and the end users was able to see the greater performance after the applications migrated to Azure by adopting the CDN and the better Azure Redis cache offering. And on the TCO side, the customer is able to realize reduced TCO of about 30 to 40%, and those costs were then utilized to enhance the application as well as build new features and better invest on the application itself, and simplify deployments with the help of the continuous integration tools and continuous deployment tools. So there are plenty of tools available such as GitHub and Visual Studio, SVN, and you can push code from the CodePlex. So there are plenty of ways where you can push the code to Azure. And IT operations labor costs also significantly come down, because now with the help of Azure and PaaS, they are not concentrating on the infrastructure side at all. Instead, they are concentrating only on the application and scaling application and making their application highly available and more secure. So key takeaways, key lessons that we learned, and we are sure that this will also help hugely when you involve yourself in migrating the application database by yourself, for your company or any other companies. So do not store anything locally. So again and again, I could say that this is a thumb rule. Do not store anything on the storage of the particular server. Always store anything, any kind of data, be it files or temporary files or XML files. Always prefer storage. But if you believe that's very temporary data, if you believe that data is not useful, and even you don't care, even if the server reboots, if the server goes down, then it's perfectly all right to store those data. But if you want that data to be persisted, better don't store on the local storage. And then always implement back off and retry logic, because cloud itself can throw errors sometimes, right? So certain services that you have chosen can take more time than you expect. So it's always better to use the back off on retry logic wherever possible, be it in the application side or be it on the SQL Server side. And understand the key limitations of SQL Azure or key limitation of any other services that we choose or you choose while you involve in the migration aspects. And especially in the SQL Azure, at the moment of doing our webinar, still the CLR types are not supported, distributed transactions still not there. So these limitations will slowly go away as Microsoft comes up with new version and new version enhancements. But at this moment, and when you look at those services, it's highly recommended to understand the capability of the service end to end before you choose a particular service. Understand the pricing and performances. All the aspects, all the services has a predefined price, right? So even if you receive a 404 error, it is also counted, right? So better understand the pricing of each of the services and then utilize cost efficiently. And if you want performance optimization with better cost, it's always good to refine your app to adopt the cloud scale. I think I'm done. I hope, I mean, the key point is that we shared will be very useful for you when you get into such engagements. Now let me hand it over to Becky.
Thank you, Ilyas. We do have a few questions to take a look at. Let's see. The first question: what's the best way to design a highly available database backend using SQL Azure?
Yeah, so I think we touched upon this particular question. So the SQL Azure itself is highly available and fault tolerant, and when you choose, let's say premium tier, the premium tier offers a highly available and redundant service. For example, when you set up a primary database, Azure automatically creates a read access replica, and it stores those data from the primary database to the secondary database asynchronously. And if the primary goes down, the secondary database it will be promoted as the primary without you noticing it. So you can look at the tier that Microsoft offers and then understand the backup and redundancy model, the business continuity model of those offerings. And if you believe there is some lack on the existing feature set, probably you can work around and find out a right backup and disaster recovery and business continuity model for your kind of application. So the SQL Azure itself, highly fault tolerant and highly available and scalable service by nature.
Okay, very good. Next question: is this webinar being recorded, and will it be circulated afterwards?
Yes, we have recorded it for the benefit of the participants, as well as the participants who could not join this webinar. We will reach out to them and we will share the webinar video as well as the questionnaire that we are discussing for their reference. Of course, yes.
Okay. Another question: what are the key target metrics based on in which we can scale the web apps?
You can scale the cloud services, and especially the Azure PaaS cloud services, using the various metrics, such as you could use the memory of those servers, and based on that you can scale out and scale up or scale in your application, as well as you can use the queue length in case if your application uses the queue effectively. And to tell you the fact, this particular application that we migrated depended on the CPU percentage as well as the disk queue length for effectively scaling out the servers whenever there was a peak load. And similarly, during the off-peak load, we scaled down the server. We scaled in the server, to 3 servers or 4 servers when there was no peak load.
Okay. Thank you, Ilyas. Another question, let's see, on what are the options available to export data from on-premise SQL Server to Azure SQL?
So like I said, there are plenty of options, but again, each of the tools and technologies offered by Microsoft has certain differences between. For example, certain services, certain tools does not move the entire schema plus the data, but certain tools will do. So again, it depends on the data that you have on premise. So if your application data is more than, let's say, 600 GB or 1 TB, you have to really look at which particular tool offers a better performance and better reliable migration of data to cloud. And if it is a simple, let's say 50 GB to 250 GB, probably you could also use other tools like BCP or import and export services that comes as part of the SSIS providers. And the SQL Server Management Studio itself has a lot of tools that will help you to migrate the schema as well as the data. But the important key aspect to note here is SQL Azure, like I said, does not support all the data types that are supported in SQL Server back on premise. So it's a key to understand the data types supported by SQL Azure, and then modify those data types to better suit the Azure SQL. And one more key point to add this particular question is for sure, your tables and database will have a lot of indexes created based on the need of the particular table. But while you migrate those tables from on-premise to Azure, it's always good to first move the data to cloud and then later index those tables, because indexing prematurely before moving the data from on-premise to cloud will greatly impact or will greatly increase the database size up to 50%, or it may take more time to load. In fact, we did a exercise doing this way. We had indexes as such on the tables back on-premise, and we tried moving those tables to Azure. And when you compared data moved without indexes and data with indexes, there's a huge difference in terms of the database, the end database size, as well as the time it took to migrate from on-premise to Azure. So it's always advisable to first move the data, first the schema plus the data, and finally create the indexes.
Okay, thank you. Another question, can you share a few of the best practices for loading data to SQL or SQL Azure?
I think we covered these aspects in the previous question, but let me also add some more points to this. So when you use the BCP tool especially, it's always best to test against your network and bandwidth and then data set, because it hugely varies based on that. And it is also advisable to split your entire data set into multiple concurrent streams to achieve a better performance while you are moving your database using the BCP or any other tool for that matter. And while building large indexes, you may notice a throttling related error. So retry using the online options as well. So these are some of the best practices that you can follow while migrating or moving the database from on-premise to cloud.
Thank you. And it looks like one last question. Can you tell us some of the deployment tools you've used in the past?
So there are plenty of options available with respect to deployment of application, deployment of code from on-premise to Azure Cloud. Especially tools like you can use GitHub, you can use SVN, and you can also use Mercurial deployment solution, and you can also use the legacy or the usual FTP and FTPS transfer protocol to push your code from your on-premise to cloud. And especially developers who use Visual Studio. So Visual Studio itself has an inbuilt web deploy option where you can push your entire applications to the respective cloud service, which is way more efficient and a better solution.
Okay. Well, thank you. And it looks like we are through with questions. I just wanted to thank everyone so much for spending the hour with us. Hopefully you found the presentation to be valuable. And if you'd like to schedule just a one-on-one call or have some follow-up questions, please take note of some of our senior management's contact information that we'll leave up on the screen here for a few minutes. Also, for those of you joining us from Canada, I just wanted to point out Prasad Sarisi's contact information for our office there. So thank you so much, and I hope everyone has a good afternoon.
Thank you so much.